Jai Hind everyone. Today we are going to start with the topic that is the concepts of pointers in C programming language. When we heard the term pointers in C, everybody is getting scared of this, right? This is a topic which is very easy to understand, but it seems like pointers, that is like a havoc, right? So let me simplify this and we'll see what the pointer is. First of all, we'll see what exactly the pointer is. Pointer, that is a variable that can store the address of another variable. In simple words, we can say if I take a normal variable, for example, I have taken an integer type of a variable a. What does it mean? We have declared a variable a which is of type integer, right? And it can store any value like this. Suppose I have initialized a is equal to 10. So I have assigned the value 10 to a. So what a is going to store, a will be having this value, right? Say in the memory, it will be stored like this and it will be having some of the address, for example 1004, fine. But if we want to store the address of any variable, then we must be having a pointer, fine. So pointer is a variable that can store the address of another variable, fine. Pointers that store address of a double, char or float, that's simply known as double pointer, character pointer, float pointer and so on respectively, fine. Now for example, I have declared a pointer variable CP, that is of type character, right? Character type a pointer variable we have declared, fine. So it is not like it is going to have the value like the address will be of character type. No, that is not, fine. What it is going to contain, it is going to contain the address of character type of a variable. Address for sure, that will be of numeric, that will be of type numeric only, right? It is not going to have a character value. What it is going to have? The address of a character variable, right? Okay. Next we have float pointer, float and then pointer variable fp, for example. This is just a user defined variable name, any valid identifier name, right? Similarly, for example, double and so on, fine. So how we can assign the value to a pointer? Say I have initialized the value of a by 10. So if I take the value of a, that will be 10. Now if I say I have declared a pointer variable, now I can assign the address of a. Why it is so? Because b is what? B is a pointer variable, right? So we can see over here we have declared a variable a and initialized it with the value 10. Then we have declared a variable, a pointer variable, and assigned the address of a to this pointer variable. So what it is going to contain? The address of a, right? So what a is? That is of integer type, right? For example, integer a, we have declared a is equal to 10, right? We have taken a pointer variable, say IP. So what we can assign now to IP? IP is equal to address of a, right? It is of type integer, integer type of a pointer variable is there to which we can assign the address of another variable, right? In simple words, we can say because IP is a pointer type of variable, so now we can assign the address of another variable to this pointer variable. Now, if we write IP, right? What is IP? What is IP? IP is address of A. If it is address of A, what it will fetch? For example, say the IP stores address of A, for example, it is 1000. So, what IP will fetch? It will fetch 1000. Okay. If I simply apply a pointer over here, what does it mean? It says value at address. I repeat, what IP will return? IP will return address of A. Okay, for example, 1000. If I am saying pointer IP, what pointer IP means? This asterisk sign says value at address. So, value at address of A. What is the value at address of A? It is 10. So, it will fetch 10. This asterisk is called as dereferencing operator. Now, we will take an example and then we will try to understand. Again, we have declared some of the variables, like I have taken a variable integer type of a variable I is equal to 3. I have initialized it as. Then I have taken a pointer variable j. Fine. Because this is a pointer variable, so I can assign the address of I to j. So, we can write j is equal to address of I, right. Okay. Now, I am trying to print the address of I. When I have initialized, when I have declared this I, it must be taking some of the space in the memory, right, and some address will be assigned to this. For example, six 5524, for example, right. So, what will be the address of I? It is 65524. Okay. Now, if I try to print j, what it will display? What it will display? J is equal to what? J is equal to address of I. I have assigned the address of I to j. Fine. When I have assigned the address of I to j, that means j is equal to what? Again, it should be the address of I, that is, for example, 65524. Okay. Next, if I say, okay, let me show you the output first. For example, we have taken, if this is the address of I, so if we are trying to print address of I, it will print the address of I simply. If I try to print the value of j, what is the value of j? J is equal to address of I. So, again it will display 65524, the same. If we try to print the address of j, fine, j is another variable which is of type pointer, of integer type only, right. It must also be having some address in the memory, fine. So, what address has been assigned to j? For example, it is 65522. Okay, fine. Now, the value of j again, it is address of I. What is the value of I? The value of I we have initialized as 3. So, the value of I is 3. Now, we see, suppose I am trying to display like this, that means value at address of I, value at address of I. What is the address of I? It is 65524, for example. When you have declared a variable, say A, it has been assigned some address in the memory. For example, it is 65524, and the value I have assigned, sorry, it is not A, it is I. The value I have initialized as 3, right. I is an integer type of a variable which has been assigned a value 3 and the address is 65524, fine. Now, what I am asking? I am asking the value at address of I. Address of I is this. What is the value at this address? It is 3. Right? Now, if we simply try to print pointer j, how it will work? Pointer j, okay. What I can write? J, pointer j? J is what? Address of I. It simply says value at address of I, value at address of I. Address of I is this 65524. What is the value at this? Right. So, that is how we can use these pointer variables. Now, one by one we will be discussing how we can use the pointers in the functions, how we can use the pointers in the arrays, and what are the operations which we can perform on the pointers, right. So, let me start with the pointers in functions. As we have already discussed, when we talk about functions, there are two methods. One is call by value, another one is call by reference. In the call by value, we simply used to pass the value of a parameter, right, and this value, or you can say the value of actual parameters, will simply be copied into the formal parameters, right. The variables, or you can say the actual parameters, that is different. The formal parameter, that is a individual different variables. What we are doing? We are just passing the copy of actual parameters to the formal parameters. The value will be copied into the formal parameters, right. So, here we have seen that we have created a function fun, and we are passing a parameter, that is a. Whatever the value of a will be, that will be simply passed over here, right. Any kind of modifications, if we are going to do any kind of modifications in the formal parameters, not in the actual parameters, we have passed the value. Now, we are doing some changes in the formal parameters that will be local to that code of block. Suppose here you are passing this parameter a, and this is a definition of the function, and what I did, x is equal to x plus 1. What is the value of x? Whatever is the value of a, that will simply be passed over here, right. So, the value of x now is 10. I am doing 10 is x is equal to x plus 1. So, it will be 11. If you try to print, what value will be displayed? 11. If we try to print the value of a, what this value will be? It will be 10. Fine. Let me write in the form of program. Right. So, what is happening over here? Because this is a local variable, whatever changes we are doing, that will be local to this function, this code of block only, right. So, it will not going to affect the actual parameters, the value of actual parameters. That is why we are saying any modifications done within the function is local to it and will not be affected outside the function. While when we use call by reference, what does it mean? We need to pass the reference. We will be passing address instead of the value now. Calling a function by passing pointers as parameters. The address of a variable is passed instead of the value. right? Instead of the variable, we will be passing the address of the variable, right? For example, now what we are doing? We are passing the reference. Say this is the definition of this function. In the earlier slides, we have seen if you are passing the address of a variable, the pointer is the only variable that can store the address of a variable. That means now I must be having a pointer variable so that it can store the address of this variable. I hope the difference is clear. In the previous slide, we have seen call by value. The value of actual parameter was passed over here and that was just copied. But now we are passing the address of this variable to this pointer variable. How does it make a difference? Instead of passing value or instead of passing variable, we are passing address. That means now I am having the original address. Whatever changes I am going to do, I will be working on the original value itself. If this is the I, for example, A is equal to 1 and it is 65524, fine. Just a second. A is equal to 1. What I am doing now? I am passing this address. I am telling this function definition, within this function definition, I have declared a pointer variable and now I am passing the reference. That means I am telling, okay, this is the address. Whatever value is there on this address, you can do any kind of changes, any kind of operations on the same only. So, if I write x plus plus, if I do any kind of changes, x plus 1, then value at x that is 1 plus 1, right. So, whatever changes now you are doing, that will create an impact over here only. Okay, let me explain through the example once again. This is the call by value, fine. Say we are displaying the value of a is equal to 10 because we have initialized a is equal to 10, fine. Now, I am calling a function and in this definition we can see we have incremented it by 1. What value we have passed? That was 10, okay, the value of x is 10. Now, I have incremented by 1, so x is equal to x plus 1, that is 11, fine. We are not working on the original value, we are just working on the formal parameters, okay. So, this value is not going to affect on the actual parameter. When after this function, again I am trying to display the value of a, it will remain same, no any kind of changes will be there. Why it is so? We can see this is a function call and this is what we have seen. Actual parameter, formal parameter, fine. So, the address of this variable is different, we have just passed the value of this variable a. So, 10 is passed over here. Now, whatever changes we are doing, that is local to this address, whatever changes we are doing, we are changing on this variable, right. Now, it will return from the function, so that will remain same, the value of a will remain same, okay. While while if we are passing the reference, we are passing the address. That means now I am asking this to do any kind of changes on the original value, right. I have passed the reference because I am passing the address, so it must be a pointer variable. So that is why I have taken a pointer variable x. Now, if you try to print the value of x, value at x, that is 10, because we have passed the value of a. Okay, fine. Now, if you try to increment this value, pointer x is equal to pointer x plus 1, I have written over here. So, it becomes 11. The value which is the original value, you can say the actual parameter, the value of actual parameter is getting changed. Look how it is working. Here in this diagram, we can see this is the same address. That shows x is having the address of A. It doesn't mean that x is not having a different address. No, A is having an address, x is also having some sort of address, because when we declare any variable like this, then this variable will be allocated some sort of memory, integer type. Okay, it will take some, for example, it is 1002. Now, if I write pointer p, again it will also be having some address in the memory, but once I am writing p is equal to address of A, that means this p is having the address of A, right. So, that is what we are showing over here, right. We are passing the address of A. So, what x will be having? The address of A, whatever the value of A is available on this address, it will be having that. So, when we do x plus plus, it will change the value of this variable, this value. Okay. So, it becomes 11. So, when it will return from the function, it will be 11, not 10. It will be changed. Okay. A and x are referring to the same location. So, value will be overwritten. What is the address of A? That is 1000. That address is being passed to x. X is a pointer variable, which is denoting that, which is saying that I am having the address of A. When it is having the address of A, whatever changes it will do, it will reflect back to the value of A. For example, another example we can take, swapping of two integers using call by reference, that means using pointers again. So, when we use pointers, that means we are passing the address of these variables. Okay, we have passed the value address of A and B from these variables. What we are trying to do? We are trying to write a program for swapping of two integers. What does it mean by swapping? Say if A is equal to 10 and B is equal to 20, what I want as an output, A is equal to 20 and B is equal to 10. Okay. Fine, we have created a function swap, and now I am calling this function by writing swap and passing the address as a form actual parameters. Okay. Now, the address of A will be passed in pointer x, address of B will be passed in pointer y. Fine. Again, that is the same thing, because we are passing the address of the variables, that is why it is mandatory to have the pointer variables. Okay. Now, we have applied the concept of swapping. For example, I have taken this value, value at x into a temporary variable, and now I have assigned the value of y to x right? And then the value of t or a temporary variable will be assigned to y. Okay. So, now either you want to display over here, then also we can do. Otherwise, I have commented this line because what we are doing, we are displaying over here, that is your wish, wherever you want to display. So, if now you will try to display the value of a and b, it will be the changed one, because we have changed the value whatever was available on these addresses, right. Now, next, moving further, we will see pointers and arrays. Up till now, we have seen the introduction to pointers, then we have seen pointers in functions, now pointers and arrays. Array elements are stored in continuous memory location, right. In the previous lectures, we have seen how we can use the concept of arrays. Arrays what? A collection of similar kind of data types, and it is getting stored in continuous memory location. What does it mean? Suppose I have declared an array of say 5 elements, say 10, 20, 30, 40 and 50. How this is gonna be stored in the memory? 10, 20, 30, 40, 50, right, at a continuous memory location. Suppose if the base address of this array is 1002, this is of type integer type of a variable, integer type of a array. It will take 2 bytes, 1006, 1008, 101010 and so on. It is not like that one element will be stored at some location, another element will be stored at somewhere else. No. It will be stored in a continuous memory location. Okay. Fine. When we talk about pointer, a pointer when incremented always points to an immediately next location of its type. That means, what pointer is? Say again, if I take integer a comma pointer p, p is equal to address of a. When I am writing or when I am incrementing something into a pointer variable, because pointer is having the address of a variable. For example, in the last example we have seen, it was, suppose, what it will does when you increment it by 1, if it is of type integer, if it is of type integer, it will take 2 bytes, right. So, when I am incrementing in address, that means incremented by 1 in the location. When I say increment by 1, if integer takes 2 bytes, it will be incremented by 2. So, it will point out the next location. Okay. That is why we are saying a pointer when incremented always points to an immediately next location of its type, of the same type. Fine. So, this is just a simple example of how we can display the address and the elements of an array using simple array variable. Say I have taken an array of integer type, say num, and these are some of the values in this array. These are the array elements, right. And simply we are just trying to display all the elements of array. So, as we have discussed, how we can access the array elements through the indexing, right. So, we have written address of num I. When the value of I is 0, I am asking address of num 0, right. When the value of I becomes 1, address of num1 and so on. In the second printf statement, we are trying to display the array elements, right? How we can access? With the array indices, right? So, simply I have written num I, that means I am asking what is the value of num 0, what is the value of num 0? It is 45, then num 1 56, 675, 42 and so on, right. So, in this example, we are simply trying to display the address of these variables plus value of elements. So, that is how we can see. For example, if the address of the very first element of array, that was 4001, because we have declared integer type of array. So, when we talk about the next address, incremented by 2. So, 4003, 4005, 7, 9 and similarly the elements. Okay. Now, we see what are the operations on pointers we can perform. We can perform number 1, addition of a number to a pointer. As we have seen in the last slide, when pointers are incremented and it is of type integer, that will be incremented, it will be referencing to the next location, because we are incrementing to the address. So, it will point out the next address. Okay. So, for example, integer I is equal to 4 and here we are having a pointer variable j. Suppose the address of I is equal to 1003 and I have assigned the address of I to j like this, and now if I am trying to write j equals to j plus 1, what does it mean? I am trying to increment the address of I by 1. When I say increment the address of I by 1 and I is of type integer, so it will say increment by 2. If the value was 1003, the next value would become 1005. Again, j equals to j plus 4. What is the value of j right now? Address of I is, we have incremented, it is 1005 plus 4. 4 means multiply by 2 plus 8. So, it becomes 1013. I repeat, because it is of type integer and if integer take 2 bytes, it will be incremented by 2. It increments pointer variable value by 2 bytes because it is integer data type. Okay. Fine. Next operation, subtraction of a number from a pointer. Say I is equals to 4 and here I have taken a pointer variable j and again I have assigned the value of I, address of I to j. Now, if I am writing j minus 2, again the same concept is there. It will be address will be decremented by 4. Okay. So, it becomes 999. J minus 5 decrement by 10. So, it becomes 989. Decrement when I am writing minus 2 decrement by 4, minus 5 decrement by 10, multiply by 2. Why it is so? Again, it decrements pointer value by 2 bytes because it is of type integer. Okay. Fine. Subtraction of a pointer from another pointer. In the last slide, we have seen subtraction of a number from a pointer. Now, we will see subtraction of a pointer from another pointer. Okay. Fine. Now, I have taken a variable, array variable and I have initialized some of the values like this. Suppose the base address of this array is 1002. When I am writing the array variable name without using subscript, that means I am talking about the base address of the array, right. So, This says if the base address of the array is 1002 and I have assigned the value of array 1, address of array 1 to I and address of array 3 to j. So, it will be pointing like this. R is what? Address of the base address of this array, right. So, it will be 1002 plus 2, again it is of type integer, right. So, it becomes 1004. Okay. So, when we are talking about 3, 0, 1, 2, 3 plus 2 plus 2 plus 4, 1008, right. Now, if we try to write j minus I, what is j? Address of array variable, array at the third element of the array minus address of first element of the array. So, it was 1008 minus 1004. Next, what we are trying to do, value at this address minus value at I, right. So, whatever the value of was available at this position of array, say 0, 1, 2, 3, 17, right, and it was 12. So, it must return 17 minus 12, that is 5. So, we can see over here j minus I 4 byte divided by 2 bytes, that is 2 in case of integer, right. Value at this, it says 5. Okay. I and j has been declared as integer pointer holding address of the second and the fourth element of the array, because array indexing starts with the 0. So, it will be the 0th element, A0, A1, A2 and like this. Here is something which is very important to note. Do not perform the following operations on the pointers. Number 1, addition of 2 pointers, because pointer is having the address of variable. So, adding the address, adding 2 addresses does not make any sense. Maybe it is not available in fact. So, it does not make any sense of that. Similarly, when we multiply addresses, that will be humongous, right. So, multiplication of a pointer with the constant nor multiplication of 2 pointers. Similarly, division of a pointer with the constant nor dividing pointer by another pointer. Also, use of modulus operator is not allowed or applicable in pointers. Okay. So, here these are few of the references from where I have included the contents in my slide.